All right, good afternoon, guys. Happy Monday. Hope you all had a good weekend and looking forward to the long weekend coming up. So if you guys were here at all last week or keeping up with the lessons, it shouldn't be a surprise to you that we finished up the unit and we're planning to have a quiz on Wednesday. So Wednesday being February 12th, we're planning to do our unit quiz then. So the topics will be everything that we've covered this semester so far. So operations with integers, grouping like terms, solving equations, simple equations, two-step equations, equations with variables on both sides, equations with brackets, and then also word problems. So at the very beginning of our review here, we're going to talk about what we started with this unit, which was operations with integers. That's not something that you're actually going to be quizzed on itself. It's just something that you sort of need to know to do the other parts of the quiz correctly. So talking about how to treat positive and negative numbers when you're adding them, subtracting them, multiplying or dividing them, sort of those rules. You're not being tested on them explicitly, but it'll sort of show, it'll come through in the rest of the questions that you do, whether you understand those concepts or not. Okay. Now, as always, you guys are going to have the full hour for the quiz. So since the ABE 1-2s are also running a quiz on Wednesday, you guys can feel free to come to class a little bit early, come at 2 instead of 2:30, so you can have that extra half hour to write your quiz. That being said, I don't want anyone to be worried about the quiz or nervous at all. It's not a long quiz. I think it's actually like 3 pages. So don't panic being like, oh, a whole hour? That's going to be crazy. Some of you probably won't take the full hour, but it's nice to have that extra time so you're not feeling rushed. You can go back, check your answers, all of your beautiful equations that you're writing. You can check all of them just to make sure that you're not stressing after you leave the quiz. The rules for the quiz, it's going to be a closed book quiz, so no surfaces, no outside notes, just calculators. So you guys can definitely use calculators. Unfortunately, the ABE 1-2s are not allowed to use calculators, so please be as honest as possible and don't share your calculators with the 1-2s because I need to make sure that they learned what they needed to learn as well. As for cheat sheets, you guys, I don't have a cheat sheet for you because I don't believe that you need one. We don't have any formulas or anything really that, like no visuals that I think you guys really need. But if you feel differently, if there's something that you think you should be able to access during the quiz and you would like to talk to me about that, just shoot me a message on Teams or send me an email and we can discuss. Okay, no new assignments this week. I never want to give you guys assignments on the week of a test because I just want you to focus on studying. So unless you're using Mathletics for practice, maybe don't hang out on there unless you like using it for practice. And if you have not submitted any previous assignments, please do that before the end of the week. As you guys know, Brock is going to be taking over the math curriculum after the long weekend, so I will not be able to mark old assignments after this week. So if you're behind on anything, please send it to me by Thursday at the absolute latest. Okay, let's actually jump into the review now. So like I said, the first couple of things that we're going to be doing here aren't explicitly going to be tested on the quiz. They're just sort of fundamental concepts that you're going to have to use for the other types of questions that you'll see. So operations with integers is one of the first things that we covered. And first thing we want to do is remind ourselves what an integer is. It's just any whole number that can be positive or negative. So by whole number, we mean no fractions, no decimal, just those nice whole rounded numbers. Then they're either positive or negative numbers. So I know you guys have seen number lines before. We have positive and negative sides of the number line being divided by that 0 marker there. 0 being sort of not really a positive or a negative number, just kind of a barrier between the two sides. And we also know how we can use number lines to do addition or subtraction problems. So in the types of problems that we're doing with algebra, not always the most practical method to use a number line because sometimes those numbers can be really big and it would take you more time to draw the number line than to really do it any other way. But just to have that knowledge and know that that is an option for you. Let's see, integer. Okay, so really what we wanted to talk about were some different tips for adding and subtracting integers, because it can be a bit confusing when we're doing them as to whether our answer is going to be getting bigger, getting smaller, or whether our final answer is going to be positive or negative. So some key points we want to point out. The first number in your equation or your operation is your starting point. So if you had, say, let's say some number plus some number, x plus y, your first number here, this x, would be your starting point if you were using a number line. So whether it's a positive or a negative number, that first number is going to be your starting point on a number line. If a number does not have a positive or a negative sign in front of it, that means it's positive, okay? And then the last key point here, the sign after the first number, so in this example, it would be this positive sign here. That actually tells you whether you're adding or subtracting the second number. So that positive sign doesn't belong to the x or the y. It's just sort of a coincidence that the y is also positive, but that positive sign is just sort of a standalone thing that shows you that this is an addition problem. So this chart might look familiar to you guys. We spent a little bit of time using it to practice our addition and subtraction. So let's talk about adding integers first. When we're adding integers that have the same sign, it's really easy. All we do is we add the value of the numbers and then keep the sign. So two positive numbers, in this example here, positive 4 plus positive 5. Add the two numbers. So 4 plus 5, that's 9. And then it's going to be a positive 9 because the numbers in your problem are also positive. If we switch that around, so same numbers, 4 and 5, but this time they're negative, we're still going to add 4 and 5. We're going to kind of ignore the negative signs for now, just add the value of 4 and 5. It's still 9, but this time our 9 will be negative because the numbers in our problem are also both negative. Okay, so really straightforward when you have the same sign. Now, when you have different signs, that's when you're going to subtract the absolute value of the numbers. So find the difference between the actual numbers. So ignoring positive and negative signs, just what's the difference between their absolute values. And then you'll keep the sign of the bigger number. So in these problems here, what that looks like is, first problem, you have a negative 4 and you're adding a positive 5. Without a number line, that can be a little bit tricky to do in your head. So what you do is, ignoring the positive and negative signs, just look at the 4 and the 5. What's the difference between 4 and 5? Okay, the difference is going to be 1, right? 5 minus 4 is 1. And your answer is going to be a positive 1 because the bigger number, which is 5, is positive. So keep the sign of the bigger number. Now, if we switch the positive and negative signs, so our question now became positive 4 plus negative 5, the difference between the numbers is still the same, right? So the difference between the absolute values of 4 and 5 is still 1, but this time our bigger number 5 has a negative sign instead of a positive sign, so our answer has to have a negative sign as well. Okay, so those are some tricks for adding integers. Now let's just do these first two examples here because they're addition examples, and then we'll talk about subtraction. So the first problem, negative 9 plus negative 14. Now these are two numbers with the, is that the first one? Yes, these are two numbers with the exact same sign. They're both negative signs, and we're adding them together. So what we do is totally ignore the negative signs for right now. We're just going to worry about that absolute value. So 9 and 14, what would that be if we added them together? Okay, if you wanted to bust out a little bit of your long addition here, 14 plus 9, 9 plus 4 is 13, carry the 1, that's 2. 9 plus 14 is 23, but it's going to be a negative 23 because both of your numbers in your problem are negative numbers. Okay, so adding those absolute values and then whatever sign your numbers are in the problem, that's the sign of your answer. So I lied and said that there were two examples of addition problems. It's actually only one. The next two are subtraction. So we'll jump back up to this before we do those. So subtracting integers is a little bit different because our method of dealing with subtraction problems is just to not do them, right? We don't actually subtract integers. We change the question into an addition problem, so it's a little bit easier for us to do in our head. the way this works is you keep the sign of the first number. So your first number doesn't change at all. You change the subtraction sign to an addition sign, and then you change the sign of your second number to the opposite sign. So if it was positive, you change it to negative. If it was negative, you change it to positive. So the example that they're giving us here, positive 4 minus negative 4. Okay, positive 4 is our first number. It's going to stay exactly the same. So it's still positive 4. Our subtraction sign is changed to an addition sign. And then our negative 4, so our second number here, the sign gets changed. So instead of a negative 4, it becomes positive 4. Okay, so now this problem goes from a double negative, so positive 4 minus negative 4, becomes positive 4 plus positive 4. So that's just the same thing as 4 plus 4, which is going to give you 8. Okay, so a lot easier to do in your head. So let's see the next two examples of that. Negative 4 minus negative 3. Remember the rules. Your first number, the sign stays the same, negative 4. Subtraction sign becomes an addition sign. And then negative 3, the sign changes, so it's now positive 3, and we don't have to write the positive sign, so it's just negative 4 plus 3. Okay, now negative 4 plus 3, not quite enough to get to 0, that's going to leave you at negative 1. So that is a nice problem with small numbers, that if you were a little bit unsure about the integers and things, you could draw a little number line really quick and do the problem that way. But negative 4 plus 3 would just be negative 1. Next question here, 5 minus negative 9. So another example of those double negatives. Keep the sign of your first number. So 5 stays exactly the same. Change the subtraction to a positive, so an addition. And then change the sign of your second number. So instead of negative 9, it's now positive 9. We don't need to write the positive sign, so it'll just be 5 plus 9. So a lot easier to deal with than that negative or that double negative. So 5 plus 9, that's going to be 14. Now, just sort of as a side note, because I did, and that's a really ugly star. Sorry, I want to do that better. Just as a side note, because I do remember mentioning this to you guys when we were talking about this originally, I have that other little trick that you can use as well. I don't know if anybody actually likes this or uses it, but like I said, I always think about it when I'm doing these problems. These double negatives can be thought of as positive. So subtracting a negative, and I always say this in my head, subtracting a negative is the same as adding a positive. So you can see that that's true, right? Subtracting a negative is the same as adding a positive. And the way that I always sort of visualized it in my head was taking that subtraction sign, sort of flipping it 90 degrees, and then putting it on top of the negative sign of your second number, right? So then it becomes 5 plus 9, which is exactly what we ended up with over here, right? So that's just one sort of little trick that I always like to use. Again, if it doesn't make sense to you, totally fine. Just keep doing what you're doing. If you like it, then feel free to, it's now yours. I give it to you. Okay, so just another little another little tip that you guys can use. Other thing that we talked about, and again, this is one of those things that I'm not really too concerned about quizzing you guys about explicitly, but you definitely need it for your algebra problems, so solving your equations, is the rules of multiplying and dividing integers. So two of the same sign, so a positive times a positive or a negative times a negative, will always be a positive answer. Different signs will always be a negative answer. So you can see that here. Okay. It's the exact same rules for division. So two of the same signs, positive and positive, negative and negative. Answer is always positive. And then when you have different signs, it's always going to be a negative answer. Okay. So I won't read those all out to you because, again, you've heard enough of it from me. Okay, so there's a couple of examples here. Let's just do two of them because I want to get through grouping like terms before the end of this class. So positive 5 times negative 3, different signs. So your answer, first of all, to 5 times 3 is 15, but then it's going to be a negative 15 because you have a positive times a negative. That's always going to be a negative answer. Next problem, you have one of those double negatives, so two negative numbers, negative 4 times negative 4. So just looking at values, 4 times 4 is 16, but since they're both negative numbers, it's going to be a positive 16. Okay, so anytime you have two numbers that are both positive or both negative, your answer is going to be positive. Okay, I guess we'll do these other ones because they're division. I didn't realize they were division. 12 divided by negative 3. Positive divided by a negative, going to be a negative answer, and it's going to be negative 4. And then negative 24 divided by negative 6. That's just like this problem here. Two negative numbers will be a positive answer. It's going to be positive 4. Okay, so just be mindful of those integers when you're doing your algebra problems, solving your equations, because it really, really stinks to get an answer wrong just because of a positive or a negative sign. Okay, so just try and be mindful, take your time. Like I said, you have a full hour, so don't rush. Okay, the first real algebra type thing that we got into was grouping like terms, and we had to talk about a few different definitions before we got into that. So the variable is going to be the letter. So it's going to be that thing that you don't know and that we end up solving for. If you guys have been to any of your classes in the last unit, you will know that my favorite variable is x, and I use it for almost every problem, but you are free to use any letter that you please. So if when you get to your word problems, you are making your equations and you decide that it's a J type of day, feel free. Like, you do you, that's great. You don't have to do x's just because I always do x's. Okay, just wanted to throw that in there. Coefficient. The coefficient is the number in front of the variable. So if you had something like 3x, x is the variable, coefficient is 3. If there's no number in front of the variable, so it's just like an x or a q hanging out by itself, that means that the coefficient is 1. Okay, so it doesn't mean 0, it doesn't mean 1/2 or anything weird like that. It means 1. Okay, so the example, the variable x can be taken to be 1x. We just never write the 1. Term. So term is the coefficient and the variable put together. So if we had, say, 4x, 4 is the coefficient, x is the variable, and then putting them together is the term. Okay. Now, my other little rant that I gave you guys is all about exponents. So remember that exponents change variables. So if a variable has an exponent, it is not the same as a variable that does not have an exponent or has a different exponent. So the example I like to use for you guys, x, x squared, and x cubed are not like terms. Even though they all contain the variable x, you cannot group them together because they're not the same. So they look similar and you see that x and you want to just jump the gun and group them together. Can't do it. Okay. Again, same thing if it's y's. So good segue into the first problem that we have here. We have a 2y squared plus 6y plus 4y plus 10y squared. Now, when you have grouping like term problem, all you're trying to do is simplify the equation. You're not trying to solve for the variable because there's no possible way you can do that, right? It's not even an equation. It's just, it is an equation, but you don't know what it equals, right? So you're not solving for y, you're not solving for the variable, you're just trying to make the equation shorter by grouping those like terms. So the first term that we have, 2y plus 2, okay, it has a kind of a friend in this equation right at the very end in plus 10y2. So you guys have to remember to take that sign that's associated with the term. So 2y squared plus 10y squared. So that tells me that I'm adding them together, not subtracting. So 2 plus 10 is just 12, and then the variable stays the same. So 2y squared plus 10y squared is 12y squared. 6y and 4y can also be grouped together. So 6y is a positive number, and you're adding 4y, which is also positive. Okay, so this becomes 6 plus 4, which is just 10. And then y, the variable, stays the same. Now, since this is a positive number, right, positive 6 plus positive 4 is positive 10, it's going to be a positive 10y. So you can take this equation here and shorten it quite a bit, take it from 4 terms to 2, and it can be shortened to 12y squared plus 10y. Let's do the next one here. 2x squared plus 7x minus 4x plus 2y minus x squared. So this one's got a little bit more going on, both in that there are more than 2 variables and there are positive and negative numbers. So we have some integer fun to play with here too. So let's sort of figure out what variables we have. So I see an x squared, I see an x, I see a couple of x's actually, and then I also see a y. So we can shorten this equation for sure, but we can only shorten it to a min of 3 variables, right? Because we have 3 different variables. If we ended up with an equation less than 3 terms long, something wrong happened, okay? So let's just start with the very first one, 2x squared. And let's find our other x squared. It's actually at the very end of the equation, and I have to take the sign in front of it as well. So that tells me that with my 2x squared, I'm subtracting x squared from it. Okay, so very important to keep those signs with the appropriate term. So remember that a variable without a number in front of it, so without a coefficient, is taken to be 1. So this is really a question of 2x squared minus 1x squared. So 2 minus 1 is 1. And our variable stays the same, so it would be 1x squared, but we don't usually write the 1, so it's just x squared. Okay, so 2x squared minus x squared equals x squared. Okay, that takes care of 2 of our terms there. The next one we can deal with is our x's, and our x's are really nice because they're right beside each other. So I have a positive 7x and I want to subtract 4x. Okay, so positive 7 minus 4, that's just going to be 3, right? The difference between 7 and 4 is 3. Because 7 is positive and 4 is also positive, right? This negative sign does not mean that the 4 is negative. It means that you're subtracting them. Okay, so remember that rule from adding and subtracting integers. So 7 minus 4 is 3, so it would be plus 3x. Last term that we have is this 2y, and it's all by itself. Like there's no other y's in the equation, so all we can really do is just write it as is, so plus 2y. So we took this from a 5-term equation, shortened it down quite a bit to 3 terms only, and it becomes x squared plus 3x plus 2y. So again, not trying to solve the equation, not trying to figure out what the variable is or anything else crazy like that, just simply making the equation shorter. Okay. I think that what we'll do is we'll end it there for today. The rest of the note is just solving different types of equations, which we will probably be able to get through all of tomorrow, definitely. Yeah, oh yeah, definitely. Now, I don't have the word problems at the end of this note because we just did them on Thursday. So if you're feeling nervous about word problems, you don't really like them, you're feeling a little bit maybe apprehensive about what kind of word problems you'll see on the quiz, definitely recommend going back to Thursday's video lesson because it was dedicated just to word problems. So I'm not going to go over them again in this review because we just finished them, but just know that that resource is there for you guys if you're feeling like you want extra practice with them. Okay. Other than that, if you guys have questions, send me a message on Teams, send me an email. Otherwise, I will speak to you guys tomorrow.